Hey everybody, we're going to talk about ecosystems, and within ecosystems we're going to talk about two main concepts: keystone species and succession, and these are the book pages if you want to refer to your book. Okay, so keystone species. A keystone species is named after a keystone in architecture. So the keystone in an arch, like our Whitney Arch, is this main headstone up here. And right there. And the keystone is this sloped stone that pushes outward and down and kind of distributes the force of the arch so that these stones here at the side can hold the arch. And so an arch doesn't stay up without a keystone. It's very important. Similarly, a keystone species in the environment is in a species that has a role in the environment greater than its numbers might suggest. So it's a species that is very important in the environment, even though there aren't very many of it. Okay, so here we go. This is biomass, or how much of something there is, and importance to the community structure. And so most organisms, if there's low biomass or not much of them organism, they're not super important. And if there's a lot of them in the environment, high biomass, they're pretty important to the community structure. Keystone species are way up here. There's not very many of them. They have low-ish biomass, but they're very important to the community structure. So keystone species support the community just like a keystone supports the arch. And there's a lot of examples. Bats and pollinators and grizzly bears and beavers and kangaroo rats. All of those are species that support the environment. And I'm happy to talk about any of these examples with you. They're all pretty awesome. My favorite probably is grizzly bears, because you wouldn't think about it. But grizzly bears like to eat salmon. Salmon live out of the ocean, but then they come up rivers to breed, right? To do their spawning and drop their eggs and sperm. We talked about that the other day. Now, grizzly bears eat the salmon from the streams, and they take the carcasses out into the woods. Like, they don't all eat them right there in the stream. And so little bits of salmon don't get eaten, and so those fall in the woods. Or the grizzly bear eats the salmon, and then they excrete the excess nutrients, what the grizzly bear couldn't absorb. And there have been studies done on trees in these woods that are pretty far away from the ocean. They're way upstream, and they find significant amounts of marine nitrogen. Nitrogen has some different isotopes that have different weights, and they've found this marine nitrogen way up in the woods, and it comes from salmon and grizzly bears. So even though there's only a few grizzly bears in an area, they're very important for spreading those nutrients. Okay, Pisaster sea star is another famous example of a keystone species. This is a Pisaster sea star. They live in tide pools on the west coast, so where I grew up. And they're pretty awesome. And this researcher at the University of Washington named Robert Payne did these studies. And so in the tide pools, there's all sorts of species, right? There's mussels and crabs and clams and sea cucumbers and just all sorts of living stuff. It's really cool. And what he did was he walked around and he picked some tide pools where every day he would remove every single Pisaster sea star. And then he'd also count what other organisms he found in the tide pool. This is a Pisaster sea star eating mussel, for example. It's called a Mytilus. And there's chitons and limpets and snails and barnacles and all sorts of stuff. Well, it turns out the Pisaster will eat any of these, but the Pisaster really likes these Mytilus snails right there. Okay? And so he's a big fan right there. And so the Pisaster will eat a lot of those. Now, when there is no Pisaster in an area, these snails take way off. There's a whole bunch of them. And the snails outcompete all of the other organisms, and so that reduces the diversity in the area. I mean, these organisms are around, but they're in much smaller numbers than when Pisaster's there. So what the Pisaster does is the Pisaster keeps the numbers of the Mytilus low and keeps Mytilus from outcompeting everything by eating the Mytilus preferentially. So Pisaster prefer to eat these Mytilus mussels. And so Pisaster is a keystone species in the tide pool because Pisaster helps make the tide pool a more diverse place. So that's what we're seeing here is there's lots of other species and mussels. Well, when you get rid of the physaster, when you take the physaster out, the mussels outcompete and there's only 8 other species that they found. So species richness was reduced and diversity was reduced. And again here, with the sea star not removed, you have somewhere between 15 and 20 species in the tide pool. Well, when you remove the sea star for a couple of years, all of a sudden species richness goes way down. Okay, and since we're back here, let's talk about another example. Beavers are a really good one because beavers make a big difference in a community. They dam up streams, and so they'll take an area that was a stream and turn that area into a pond. And that can also be a big influence on organisms in the area because beavers take fast-moving water and create large, slow ponds. And so beavers are ecosystem engineers. They change the ecosystem, and they have a really big impact on the environment. Okay, so that is Keystone species. Let me know if you have questions after doing the biozone worksheets. Then the other concept we need to talk about is succession. Communities change over time. No community is the same forever and ever. That just doesn't happen. Why? Well, the communities respond to climate, to environment, weather changes, water patterns, things like that. And also just over time, things evolve. And then also just some things only live well in certain types of habitat and not in others. For example, some trees only grow well if they get full sunshine. And when other trees grow up and those little babies can't get any more sunshine, they don't grow well. But there's other species of trees that don't mind growing in the shade and then grow up to be big trees. So, for example, oaks like full sun. And so oaks are one of the first thing to grow up in a forest. Well, baby oaks don't like to grow in the shade of big oaks. But maples don't mind it. And so eventually a forest will change from an oak-dominated forest to a maple-dominated forest based on whether or not their babies like to grow in shade or not. We can observe some trends in succession. This isn't per se prescriptive, but it's kind of a trend that people notice. And the AP exam has some questions about it historically. Know that some communities experience a lot of change and challenges, and so they never reach certain stages of succession. For example, prairies or the chaparral community in California, so these are both kind of scrubby areas with not too much rain, they both are fire dominated or fire controlled, and so the fire keeps those areas from turning into forests with trees because fire comes through periodically and kills all sorts of organisms. But the prairie grass and the plants in the chaparral are adjusted to fire, and so they grow back right away. And so, for example, a prairie will never become a forest unless we suppress the fire because that's just the community experiences a lot of change through the fires. Okay, primary succession is the first kind of succession. And the main thing you have to know about primary succession is that there is no soil. You start with bare ground. This is what happens after maybe a volcano or a glacier goes by and scrapes off all the soil. And the first things that happen is that you get lichens. Lichens are an organism that is a symbiosis between fungi and algae. A lot of people will call lichen moss, but lichen isn't a moss. Lichen is the dry, crusty stuff on trees. Moss is really soft and damp. Let me know if you want me to show you an example outside. I can find some for sure. Lots of trees have lichen on it, and people just mislabel it. Anyway, lichens come in, and they help break down the rock and produce some soil. So some soil gets produced and decomposing stuff makes soil. Then we get small plants, then slightly larger plants. Then we start to get shrubs and some trees that like full sunshine. And then ultimately we get a forest. And that's our climax community. And climax community is the name for the quote-unquote final community. But again, like ecosystems always experience change. We're never going to get to a point where the ecosystem won't change at all. The main thing with primary succession is that there is no soil and you start with bare ground. Here's lichens. Lichens grow on rocks and they break down rocks into soil. That's what's happened here, and you can see some little flowers can grow in there in the soil. But this is lichen. It comes in all different colors. It's pretty sweet stuff. Yeah, my favorite joke about it is Fred fungi and Alice algae took a liking to each other. Yuck, yuck, yuck. Come on, somebody's got to laugh. Because a fungi and an algae are in a symbiosis together. Anyway, there you go, lichens. Secondary succession is after disturbance, but you still have soil. So you have a forest fire or a big flood or something, but you still have soil. And so some disturbance, and you get pioneer species. Those are the first producers that come in. So you should know that term too. Pioneer species come in. And then over time, you go from having small pioneer species to slightly bigger ones and slightly bigger ones, and eventually get large trees and trees that don't mind shade. And again, that's your climax community. So primary succession is no soil. Secondary succession, soil is present. Both of them have to happen after disasters. Obviously, primary succession happens after a bigger disaster. So that is my PowerPoint on succession and keystone species. I hope that was helpful, and let me know if you have questions. Thanks.